We're going to do lab 1 in just a minute here, but I'm down here in the plastics lab, room 122, I believe. And we were supposed to do a lab tour on the first day, but we didn't because I didn't want to walk around with my phone. But we're actually down here now, and you'll see more of this when you come into the lab to do lab 3 and 4 and 5 and 6. But I wanted to show it to you really quick. So actually in lab 3 is the first thing you'll do. So we are going to use this machine right over here. This is the automatic Rockwell hardness tester. And the controls for the machine are mostly up here where you're going to select the correct scale to use, whether it's Rockwell B or C. And we'll talk about all that. The indenters for the machine, this will make a lot more sense in a week or two, but all the indenters are kept over here. And the start and stop buttons are just right here. And we'll talk a lot more about this in a little bit, but it's a very easy machine to run. It's called a Rockwell automatic hardness testing machine. It's about $25,000. So I only have 2 or 3 of those in my basement at home. Don't need too many of those. Also, I want to point out the Instron UTM, Universal Testing Machine. So that is this piece of equipment right here. It has a maximum capacity of 100 kilonewtons, which is about 22,000 pounds of force that can be exerted either in tension or in compression. And we have a whole bunch of fixtures that we keep over here for compression and for bending. That's what this thing is. And for compression, that's what these are. And the ones that are in here right now are the tensile testing grips. So in lab 4 and lab 5, what we'll do is take the specimen, and you will insert the specimen into the jaws and crank them down into the jaws. And then you will come over to the computer and you control the test from the computer. So we're going to be using this machine quite a lot in labs 4 and 5 and 6, and again in lab 8, and then again in lab 9, which is the very last lab in the class. All right, so with that, let's go ahead and set this down, and then we'll get started on lab 1. Okay, to get started on lab 1, I have my lab manual sheet for page 1 right in front of me. You should too, as you're following along. And for all of the labs in the course, you should always have your lab manual to follow along with you. All right, so for the materials that we're going to need a scale. I've got that right here. We're going to need a ruler or tape measure. I've got one of those right here. We've got a graduated cylinder with some wire in it, some water in it right here. And we're going to need a wire to dunk the specimens in there. Safety glasses, check. Is it ridiculous that I'm wearing safety glasses as I'm measuring the dimensions of materials? Absolutely, you betcha. But it's just a good habit to get into, and it's a professional habit to get into. So that's why we make you wear safety glasses for all the labs in this course. Even though for some of them, like the first couple of labs, yeah, it's a little ridiculous. And then we've got all of our specimens. We've got a steel specimen. We've got an aluminum specimen. We've got a copper specimen. Then for the plastics, we've got an ADS dog bone. And we've got a polypropylene dog bone. And we've got a chunk of high density polyethylene HDPE. All right, this one, we're just going to measure to get the dimensions, not going to measure the displacement of that one. And our different kinds of wood, we've got oak, and we've got mahogany, and we've got walnut, and we've got white pine, and we've got hickory. All right, so we went through the procedure last time. So what we're going to do is measure the mass. We're going to mass all of the materials, specimens, and then we're going to calculate the volume in different ways depending on which shape the material is in. So what I'm going to go ahead and do is I've got the scale right here, and I know I'm going to have to find the mass of all of them. So let's just go ahead and do that first. So you need to record all of these. I'm not going to put this data on RegNet. You need to record these as I'm talking through these. All right. So I'll try to make it as easy as possible for you. I'll even go in order that it lists on here. So our first specimen is 1095, which is a high carbon steel. So let's get the mass of this. And this is all going to be in grams. All right. So steel specimen is 82.83 grams. Then we've got the aluminum specimen. The mass is 35.49 grams. Then we've got the copper. The mass is 119.06 grams. Then we've got the ABS plastic. So this is just a little plastic dog bone. 7.25 grams. We got the polypropylene dog bone. 7.08 grams. Now we've got the chunk of HDPE. Cripes. All right. Now we've got the chunk of HDPE. Oh, you know what? I'm going to have to measure this a different way. This exceeded the capacity of this scale. So I might have to find a different scale to measure that. Let's see if the others do. We've got oak. Oh, that exceeds it. Mahogany, that's the one that fell on the floor. Mahogany is only 197.81 grams. And walnut, this is probably going to exceed the capacity. Yep, that exceeds the capacity. White pine is 148.61 grams. And the hickory, this might exceed the capacity. Nope. Okay, this hickory is 254.30 grams. All right, so that scale, I forgot that it has a capacity that is not quite big enough for these three specimens. So I'm going to go find a different scale and we'll measure the mass of these on a different scale. All right, I'm over here in the plastics lab, just in the room right next door, and I am going to measure the mass of those three specimens with a larger scale. So let's do the HDPE first, and this one is 464 grams. The oak specimen is 346 grams. And the walnut specimen is 496 grams. All right. So. Okay, now that we've got the mass of all of the specimens, we're going on to part A in lab 1, and this tells us to measure the displacement of these specimens that are kind of irregular, like the metals and two of the plastics. So what I'm going to do is take my piece of wire and wrap it around this metal specimen, and that will allow me to dunk it into the water and measure the displacement of the water. All right, so that should work, but we're going to need to know the initial displacement of the water, and the initial is right at 70 milliliters. 70 milliliters. So now we just need to dunk this in here, make sure it's submerged. And now the displacement is right at 81 milliliters. So you can take that and you can convert that into cubic centimeters, and then you can convert that into cubic inches using the conversions provided. So that was the steel, 1095. Let's do the aluminum next. Wrap it around. Once again, the displacement should be 70. Yeah, it's at 70, the initial displacement. I'm going to submerge the aluminum. And this one's just a little bit more. This one is now, this is at 82 milliliters. So it looks like the volume of the aluminum was just a little bit bigger than the volume of the steel. Okay, I'm going to unwind this. And let's do the last metal now. You know what, there's no place to really wrap this, so I'm going to save this for last because it's really hard to get out. So I'm going to save the copper for last. Let's do the other plastics, the dog bones. Okay, what I realized was I was going to need a little bit more water in the graduated cylinder because the height of these dog bones needs to be fully submerged in the water. So I put a little bit more water in, and now the initial level of the water before submerging the plastic is at 87 milliliters. 87 milliliters. So now let's dunk. This is the, did I switch it on you? This is the polypropylene. So initially 87, this is the polypropylene. Let's get it in there, there we go. Okay, it's fully submerged. And now we're at 94 milliliters, all right? 94 milliliters, before it was 87. Okay, and then now I would expect the ABS should be virtually identical, but let's go ahead and do it just to be thorough. So here's the ABS dog bone, and it's still at 87 milliliters initially. Submerging it. Now it's fully submerged. And yes, it's 94 milliliters once it's submerged. All right, so that gives us we've got the steel, the aluminum, the two plastic dog bones. All that's left is the copper. I said I wanted to do this last because after I get this in there, there's no place to wrap something around really and have any grip on it. So I'm probably going to have to, you know what, the water level is probably too high. Okay, the water level is just a little bit too high for the copper because once I put the copper in, I was pretty sure it was gonna go up too high beyond the markings of the graduated cylinder. So here we go again with an initial reading. The initial reading is 69 milliliters of water. Now I'm going to slide the copper in there. And now the new height is 82 milliliters is the new volume with the copper submerged in it. So now you can calculate all of the volumes for the three metals and the two plastic dog bones. And all we have left to do, after you do the calculations in part A, of course, we can flip over to part B. And all we have left to do in terms of the data collection is measure the dimensions of our 5 pieces of wood and our chunk of HDPE. So let's do the HDPE first. I'm gonna measure the dimensions to the nearest 1/16 of an inch, all right? So you're gonna need to convert fractions into decimals as you're calculating the volumes, all right? So I'm gonna give you the dimensions of the high density polyethylene. So the length of the high density polyethylene is 13 inches and 6/16, which you could reduce to 3/8. Length is 13 inches and 6/16. The width is exactly 3 inches. And the height is exactly 3/4 of an inch, or 12/16. All right, so that was the high density polyethylene. Now, I'll try to go in order that they are listed to make things easy for you. So we got the oak first. So the length of the oak is exactly 8 inches. The width of the oak is 3 13/16 inches, 3 13/16 inches. And the height of the oak is 13/16 of an inch. That's the oak. Then what's next? Mahogany. Here's our mahogany chunk. Length of the mahogany is 9 inches and 13/16. 9 13/16. The width of the mahogany is right at 2 inches. And the height is 15/16. 15/16 of an inch. Next, we've got walnut. Here's our walnut chunk. The length of the walnut is 11 14/16, or 7/8. 11 14/16 inches. The width is 2 9/16 inches. 2 9/16. And the height is 1 9/16 inches. 1 9/16 inches. Next, we've got white pine. And the length of this specimen is exactly 12 inches. The width is 1 15/16. 1 15/16 inches. And the height of the white pine is 12/16 inches. 12/16, which is 3/4. All right. Now the last one is the hickory. So the length of the hickory specimen is 11 15/16 inches. The width is 1 14/16 inches, which is 1 7/8. And the height is 12/16, which is 3/4 of an inch. Okay, so that is all of the raw data. Make sure you follow the instructions. You're going to need to put all of that raw data into a table and then perform the calculations on it. And that'll take you through section B after you've got those calculations done. So after you do those calculations to convert into pounds mass and inches cubed, you can calculate the density, and then you can move on to step C in the lab instructions, which is to go to matweb.com and look up the ultimate tensile strength. Okay, and then you can move on to the results section and then to the discussion section. Okay, so that's all the data that you need to complete lab 1. Let me know if you have any questions. Refer to the schedule to find the due date. I don't want to misquote it here, but it's on the schedule. Make sure you attach your calculations page, upload that to RegiNet by the due date time on the schedule. All right, that's going to wrap up lab 1, so I'll see you next time.